Hi guys, so this is a third video on integration in further maths, and we're moving on to exercise 3E, and this is integration using further partial fractions. I picked up question number 6 from the book. So I've divided this page into two halves. I will try and do the partial fraction bit on this side and the integration bit on the right side, okay? So partial fractions. I will try to factorize this denominators. What do I get, guys? I get x squared plus 1 and x squared minus 1, which this difference of two squares, which further gives me x squared plus 1 and x plus 1 and x minus 1. So I've got two linear factors, which I've used in normal maths. And this, I've got one quadratic factor. That's where the difference is, guys. So I will write this down as x cubed plus 9x squared plus x plus 1 over x to the power 4 minus 1 is equivalent to ax plus b, a linear function at the top, because there's a quadratic at the bottom. I can't factor this any further, plus c over x plus 1 plus d over x minus 1. Okay, if you know this already, guys, you can try and find the partial fractions for this yourself, and you can do this, you find these two values by putting x equals 1 and x equals minus 1 on both sides. And for this one, you have to compare the coefficients. Give it a try. We'll work them together, otherwise a little later. This is very easy. Now I'm going to try and substituting x is equal to 1 first. So when I substitute x equals 1, it's 1 plus 9 is 10, 10, 11, and 12. Check if I'm doing my calculations right. Is equivalent to x plus 1. Putting in here, that gives me 0. Putting in here, that gives me 0 as well. So this is the only thing which does not give me 0. That's d times 1 squared plus 1 is 2, and times 1 plus 1 is 2. So I've got, guys, 4d is equal to 12. That gives me d is equal to 3. Okay, that's your normal maths. Okay, so x is equal to minus 1 to get the second bracket equal to 0. So minus 1 cubed is minus 1. So minus 1 plus minus 1 squared is 9. So minus 1 plus 9 is 8. Minus 1 squared is 1, so that's 9. So 8 minus 1 plus 1, 0. That's just 8. So guys, 8 is equal to, when I put x equals minus 1, I'll get this bracket 0. I've got this bracket 0. This is the only one I don't get 0. So I got c times minus 1 squared is 1. 1 plus 1 is 2. And minus 1 times minus 1 is minus 2. So guys, got minus 4c is equal to 8. So c equals minus 2. Okay, for the third one now, guys, I cannot put any more equal to 0. So what I'm trying to do, I'm trying to compare the coefficients. Okay, coefficients of, let's say, any term. Let's pick up x cubed. All right, guys, x cubed coefficient on the left side is 1 is equal to, I'm going to get x cubed from here. So ax times x is ax squared times x is ax cubed. So there'll be a there. Okay, I'm going to get x cubed coefficients here as well. C x squared times x is x cubed plus c. Okay, I'm going to get x cubed coefficient here as well. So this is d plus d. Okay, so I've got c and d already. That should help me find out a. So that is what? 1 is equal to a plus 3 minus 2. So I got a plus 1 equals 1. Do I get a equals 0? Check, guys, is a equals 0? Check if that's what you got. Okay. Then I compare the coefficients of any other term. Let's do it for x squared if you want to, or let's do the constant term if that helps. I've got 1 there on the left side. That's a constant term. So constant term from here, I will get b times 1 minus 1 minus b. Okay. And c, I will get constant term c times minus c as well there. And d will be plus d. So let's see if we get something somewhere over here. And so 1 is equal to b minus c is b plus 2 and plus d is plus 3. Okay. So I'm looking like b is minus 4. Check for me. I'll ask you to pause. Check for me if these partial fractions are correct or not for me. Thank you. I'm glad I stopped myself and checked again. I've made this mistake. There was a negative b, it's negative b there, b equals to positive 4. Okay, so this integration can be written as 3 partial fractions. Now, let's write down these 3 partial fractions, then we start integrating that. Okay, so this is where we reach. So partial fractions are done. So we're going to integrate this. So let's integrate these 3 separately. let's see how does that work, people. So this will be integrated using the formulas because that's an a squared plus x squared. I want 1 on the top, so I'll take 4 outside. This is integration of 1 over 1 squared plus x squared. Okay, this will be just straight ln. So because differentiation of that is just 1, so there'll be 3 ln x minus 1, and that will be minus 2 ln x plus 1. Okay, so using the formula over here, we can get this to 1, 4 times 1 over 1, because a is 1, arc tan x over 1, because a is 1 there. Okay, so that will be 3 minus 2, right? So I can do this as now, if I combine this using lens or logs formulas, that'll be ln x minus 1 to the power 3 over x plus 1 squared. Hope you know that this power can go up on the top, and then there's a subtraction tool in terms I can divide them. Right, so finally I write this as 4 arc tan x plus ln x minus 1 to the power 3 and x plus 1 to the power 2, which I look here, this is exactly the form I want. Okay, so comparing this here, guys, I got my a is equal to 3, my b equals to this one, and d is equal to 4. Right, so I have been able to show this using partial fractions and one of the integration formulas which are given to me in the formula book. All right, the next question we pick up is question number 8. It tells me to calculate that this is obviously normal maths question, so I wouldn't expect you to do this yourself. Then we check if this function diverges or not. So guys, can you please copy this question and work out making partial fractions, work out that integral, and then we're going to be trying to do what? We're trying to do part B. So there we are. Can you just start this part A for me? All right, so these are my partial fractions. Now we're looking at the integration. So obviously this comes out. So what's the differentiation of this is 1. So that's sorted. This is equal to 1/3 ln x minus 2. What's differentiation of this is 2. So this will be 1/3 2 over 2x minus 1. So that gives you 1/3 ln x minus 2 minus 1/3 ln 2x minus 1. Okay, so this can further be written neatly, I would say. This is 1/3 outside and ln x minus 2 on the top and 2x minus 1 at the bottom. Okay, and then you can take this 1/3 to the power as well if you need to. So that is your integration. Okay, obviously the all equivalent forms are accepted. Right, so part B, we have to evaluate this integral between these limits. And guys, this is a classic example. So I'm glad we're doing this question. Have a look carefully. If you put x equals half, this bracket becomes 0. So this becomes infinity. This function is not defined at that. And if you put x equals 2, this bracket becomes 0. That means this function is not defined at any of the two limits. So what do we do in this kind of cases, people? We haven't done a question on any of the videos before for this, but what you need to do is, guys, you split this in 2 parts. Okay, the 2 parts means you start from half and there's number there, and then plus that same number at the bottom and go up to 2. And make sure you want to find a number here for which the function is defined. Okay, so we can put 1 here. This is defined 1 because if I put 1, that becomes 1 at the bottom, and minus 1, this function is defined. Okay, you can put anything, but keep it as simple as you can, guys. And 0 doesn't come in between half and 2. That's why I don't put 0. Otherwise, 0 is the best number to put in that way. That helps you integration properly, because 1 and 1. So I'm going to be integrating these 2 integrals now with that, obviously. Okay, so let's try. And now what happens, guys, for this first one, the function is not defined at the bottom, so I put a t there. And for this one, the function is not defined at the top, I put a t there. Give it a try. We've done this in the first video. So we write them in limits like this, people. Then I've got the integral of, look carefully. So half t goes to half because function was not defined at half. So I put a t there and 1 stays there on the top. and t goes to 2, because function is not defined at t at x equals 2. So I put t on the top there. So guys, I've got the integral for this, which is that. So I'm going to be writing down the answer, substituting the values of 1 and t, and see what happens. Okay, so I'll pause it again, just to shorten the length of the video. Put that in this answer in both the integrals, put the values of 1 and t there, put the values of 1 and t there, and see what happens. Okay, there you go. This is where we reach finally. We'll look at it now, guys, carefully. As t goes to half, I substitute that into it. This obviously is not defined, enough negative number. And even this goes to infinity. Okay, as t goes to 2, this part goes to infinity. So this function cannot be evaluated. That's why, what do we say? That this function between these limits, it diverges, because we cannot evaluate this. We're not able to use these two values and get an answer to this function. Okay, the infinities are not coming in the denominators for us to get an answer. Okay, so this is your integration using partial fractions. Thank you.